Welcome to week 4. In this week we will start taking a look to POPs, that is the particle system from Houdini. And right now you will understand the real importance of using the sub level. What's the sub level? We've been working while creating under object level a geometry. That's the name is particles. We have been working this level. This means that the sub is a surface operator and includes all the modifications and attributes that you add to an object. That means adding normals, colors, deformations, whatever change we've been doing till here happens in the sub level. Now talking about dynamics, this happens in another level. It's the DOP. That means dynamic operator. So by creating a DOP net, everything inside here we have our physical calculations, collisions, gravity, and other stuff. And also not only particles which happen here, but also rigid bodies, pyro simulations, flip simulations, everything that has to do cloth, everything that has to do with simulations happen inside here. You can also create pop that it basically creates the same that we have seen right now, but it creates a kind of preset, so it's easier for you to start and don't start creating everything from scratch. You can do everything from scratch just by creating a DOP network. You can create a pop solver, just copy all the same nodes that you have inside here. As a personal choice, I really prefer to start from here, as it will earn a lot of time and the result will be exactly the same. Okay, let's create a sphere. Sorry, that one. And we will use this as an emitter just to show you how this works. Where are the emission options? We can add attributes, we can have gravity, turbulence. I'll show you the basic nodes for this. Let's set up this sphere as a polygon. Let's leave it as frequencies 2. And you will see that the POP network or any other DOP network will have 4 inputs. You can connect, make different connections about different objects, and then look for them once you are inside. You can also reference objects from outside and from other levels. Let me show you. Let's plug to our first input. And we will see that we'll get our sphere in a kind of blue wireframe. This means that our emitter is already connected. So here in the pop source, we'll get the emitter attributes. You can get a emission type, scatter onto surface. This will do exactly the same as creating a scatter node in the sub level, and then plug in the points. It will convert your surface into points and emit based on that. You can emit from all points. This means that every single, let's say, vertex will emit particles. Nothing will happen because we need to add a force. Let me add it so we can see clear what's going on. Every time you create a node for pop in this pop doc, you will first need to write pop and then the node that you are looking. This means that it's 100% compatible with these systems. If you probably add, I don't know, a gravity, and you say, okay, I want to plug this gravity force, you will get an error because it's not compatible for this pop setup, but it will be useful for a flip simulation, that is a water simulation from smoke simulation, but not for particles. So the best way to add a gravity, I like to use the pop wind. I will show you after showing the emitter, so I'll just set the amplitude to 1. And now we see that we have emissions on every single point. Also, you can set up a number of points, not the total amount, but a numbers. You can see that it's almost the same. That's why you have to move to the birth. And here you can see the number of particles that will be created per second, not per frame, per second. So let's say 5 particles per second. You will see that not all the points will emit particles at the same time. But if we decide to change this guy to all points, you will see that each point will emit 5 particles. So this is it for the emitter source. You can also see that you have a geometry source, that is the first content geometry, as I told you some minutes ago. You can get the second context, the third or the fourth. For example, if you get the second context, you will see that nothing happens here. That's why you need to plug your emitter to the second input, and now see that it's working. This is useful if you want to plug a different kind of emitters, not only one emitter, but some of them. But we can also plug objects from other levels. What happens if I decide to work? Let's create a geometry. Let's name it emitter. Let's delete this guy and create also, I don't know, let's say a box. Let's say I want to emit from this object, but you are far away to plug it. There are 2 ways. The first way, there's a node that is also used a lot called object merge, in which you can import an object from other levels. For example, here I can dive inside the emitter and get my emitter box. If I put my flags, my display flags here, we'll see that I get this exact same object and plug it. Nothing will happen because we have selected the second input. So here we have our box. Other way, just let's say I want to plug 5 different emitters and I only have 4 connections. What you can do is, instead of using geometry source first contact, you can use parameter values. Here it's set SOP. Remember that it's surface operator, so you can dive inside your network and pick up your box. Let's rewind. Sorry, it didn't pick up. There it is. So now we see that we can also source our emitter from other place of our scene file. Okay, let's go back, plug first input. Let's leave this as it was. .network and points. Let's save this as week 4. Basis English. Okay, perfect. First contact. Now we have the birth. Yeah, this will. You can set the amount of particles emit during, as I told you before. Also, you have a constant activation if you want to turn on and off in an easy way. You can set it up to 0 and you have no emission in case you want to animate this stuff. And also you have a life expectancy. If you use particles in other software, it's like the lifespan of the particle, how much time it will live. It's also in seconds, and you can add a variance just to get some randomness. So not every particle dies at the same time. Let's go back and use, I'd like to use the scatter into surface. You will see that the scatter will do some variations over time. And for what I want to show you, let's leave it as points. Because we'll start taking a look to the pop wind in a while. So, okay, now we know what life expectancy variance do. We'll take a look to these guys in a while, because you can connect, you can create velocities and different random emissions in the future. And that's it as source. Also, one important thing you can do is to add a name to the particles created. There will be a group made automatically by Houdini, just by hitting middle click mouse. There's a point group, stream source first input. So now we have 1,000 particles, and this means that all the particles generated in this node will be named like this. This will be very important in the future, because we'll also make a range setup, and just to get some collisions on the floor and make a secondary pass. This will be very, very useful, and also learning how to manage group will be very important. Pop wind. So we can get a point wind velocity. If you set it to negative 9.8, we'll get gravity. Let's set up a bit more particles. And you will see, once hitting play, you will load a blue bar down here. This means that your cache is being saved on disk or memory. So if you change any value, you will see it will turn to orange. This means that it's not updated, so you have to rewind and play that again. Once it's loaded, you will see it very fast. It's not it's not real time, so you can hit this button here. It's the real time toggle, and you will see your simulation in a more accurate speed. There's also a way to do your flipbooks. It's right here. You can right click your mouse button and go to the options. You will have a variable here that this is it will take your first and last frame from your timeline. If you want to modify this, you can directly type the number you want. Let's leave it as it was. Rather frame. And you can also remember you can change the start and end from your frame from your project right here. So if you click start, a new window will pop up, will load your cache, and you can play it also in real time. And you can set up the frames per second if you want to, I don't know, modify. It's a nice player. You can, it works really very good, and then you can probably save your sequence. Okay, let's go back to our pop wind. Here you get the gravity. There's an air resistant attribute. This means if air resistance is 0, you will have this force won't be affected at all. If you turn it to 1, gravity will happen again. Down here you have the noise options. You can set, let's set down to 0 just to see how this works. Okay, now you see you can change the amplitude. This is the magnitude of the noise. Let's put this guy a bit lower. Very little will happen there. There we are. The swirl size is the size of this turbulence. The bigger, and you can test the different size. You can also change this scale from our 3 different axes. There's also a pulse length. This guy is the, let's say, the turbulence animation. If it's set up to 0, you won't have animation on our turbulence. Let's increase this life expectancy. If you use lower values, animation will be very fast, and at higher values we get a lower, slower turbulent variation. The roughness is how hard this turbulence is. So the lower will have a nice curves, more harmonic. If we set up to 1, it will break a lot. We have a lot of noise. and turbulence also to get a different kind of turbulence on our simulation. Okay, so this is our pop wind. Let's take a look to our the most important node. It's the drag and pop property. Drag, it's simple. If you've used particles in other software, this pop drag is the damp, the energy lost. The higher value, your particles will lose energy and won't move that fast. If you set them to 0, you will get them moving free. Also, let's plug the pop property. This pop property node, it will allow you to add some extra properties and variations to different options of the object. For example, let's turn on mass. Let's see what happens first. You can access to every single particle attribute here in the geometry spreadsheet. Go down to your pop object, and inside geometry you will get each particle and all the properties that a particle has and values. You can get position, the age, space on the life expectancy, resistance, depth. It means if it's in a group that has the particle has died. Let's see. Also, there's an ID, and you can get velocities. Let's see what happens if we add mass. We'll see that mass has been added. Right now it has a value of 1. If we change its value, it will update. And there's a way to randomize this value, so every particle has a different value. You can access that by activating use VFX expression. I won't drive you crazy right now adding some code lines, so we can use some presets that Houdini brings. And here we can see an option called randomize mass. This is exactly what we wanted. Now with this guy, turn it on, you will see that the mass, every particle has a different mass. So let's read this and see what's going on. The first line is a float seed. This means that we create an attribute called seed, which result will be a float number, 1.2, 0.9, no integers, no vectors, just one number with comma. And this is a random seed, so this is the value for this attribute. And now what's happened? Here we have a mass. It will multiply this value by our already known friend fit01, and it will generate a random number based on the ID plus this attribute. So remember that we get this ID from here. So every particle will get a random noise, as this value will be different in every case. And we will fit a number between 0.7 and 0.1. Let's say we want to change to 10. We'll see how our mass will have higher values. What's the difference of a low number mass and a high number mass? The higher the mass is, the heavier the particle will be, and it will take more energy to move it. So, if a lower mass, the particle will be faster as it's lighter, and for normal magnitude force, you will get a faster result. Let's see what's happened in our particle simulation. So you will see that there are faster particles, there are slower particles. It means that they have their variations on mass. Once you get in collisions, you can activate bounce and friction, and you can do pretty the same. Copy this value, paste it down. So now we need to get the friction, for example, of the bounce attribute. How do we get this name? Just by putting over the attribute, you can see that you will get a parameter bounce. You have to type exactly the same way. Okay, let's type bounce, and let's do the same for friction. Friction, you get parameter friction. Awesome. If you go to our geometry spreadsheet, you should have friction and bounce and friction, and everything is randomized. You will see that you have the same values. You can change that. Instead of doing plus the seed, you can put a random number, and you will see how the friction will be different as the bounce. The same for the bounce. You can set this guy, for example, to 10, and now we have different values in all cases. You can also play around and change the fit. But these two attributes, you will get them. You will see them once we have collisions. You can also add some dynamic as drag and other options that we'll see later on. Let's save this in. Okay, if we keep going down, we have a wire pops into here. What does this mean? That you can get different trees, different emitters. You can copy paste this and plug it here, and everything will calculate under the same solver. This solver is where all the magic happens, where all the calculations and things will occur. You will also get this pop object. You won't have much things to play with in here. We will change this stuff later on. And inside our pop solver, we can change the time scale, and you also play around with substep. We'll also see next week how this works. But for now, the important thing is that you can get collisions and detect collisions from here. We will do right now rain setup. and you will see how we can add a heat number, and it will color the particles while they hit the surface, the surface or the collision object, and you can give a behavior to that collision. So this is a bit the introduction. Let's save this, and now let's move to our first setup. Let's delete this emitter, and what I will do is I will create a grid, because we will do a rain setup. You will see the important thing about working on the meters. Doing a correct emitter is the 50% of any simulation. If you don't get a nice emitter, your simulation won't look as natural as all. So I recommend you to add as much random as you can to your emissions, playing in the sub level. We will adding deformers, playing with the point bob, adding different velocities, adding deformation to the surface, using a bit what we have already applied to your emitters. So let's go to our first exercise. Just let's put these words into practice. This will be our emitter. Let's move it up a bit. Okay. What I want to do to this guy is to add point normals. So let's add a point node. And what you can do here is to select the attribute you want to modify, and under VFX expressions, let's use a constant value. You can test these guys and see what's the effect you get. -1. And let's turn on our normal display. You can play around with this value and see you can get random values. You can these as starting points, but let's for now keep it this way. I would like to add a color attribute just to have it there. Add CD, remember how our attribute is named, so CD and normal position. And I want to add a point pop. What I will do here is to add some random directions, also some random on the randomness on the normals. So this means that the shorter the normal is, the slower the particle will emit. We will plug this to the velocity, and the longer the normal will be, the faster the particle will go down, and we will get some nice variations on that emission. So remember, this is the input, this is the output. Right now we have position, we have color, and we have normal. I will add turbulence noise. Plug to our position, and I will multiply by our current normals. We'll set up the turbulence noise to 3D noise. This is the same, this can go, the order doesn't alter the result. And the product, let's move it to normal and see what's going on. Okay, nice. This is a bit what I wanted. Now you see we have some variations. We have a shorter and longer that will give different velocities. The higher the amplitude of this noise is, the more variations that you will get. Also, the roughness will give us some more, let's say, not that random normals. If we increase this value, we'll get what we are looking for. Probably let's go down a bit. And let's plug this guy to our V velocity, and this way it will create our velocity attribute. Okay, so right now we have our velocity normals. We'll change this a bit. Let's try it on our first input. And let's go back to our attributes. We remind this because it was better to take a look right now that we have attributes. This guy, what it will do, it will pick up all the attributes from our source, from our emitter. You can get them listed here, and we can use it as an emission. Let's set up a velocity, and here we'll set initial velocity as using generic velocity, and this value will be 1. Let's turn off, bypass our rest of nodes, and see what happens. Let's turn off also the velocity. Now we will see how some particles are faster than other ones because of this velocity attribute. You can set up this value. To get more magnitude. And also let's add a bit more particles. Okay. What I don't like is that all particles go straight down. We'll add later on some pop wind, but I also want to add let's move in here, and we'll see that our mission is straight down. Let's add a bit of random. And now we'll see that our random velocity has also a bit of direction. Probably these particles are going very straight to a direction that we don't want. So let's modify these values a bit. There we are. What you can also do is to add some deformation to this geometry. I like to use my mountain or also point bob to the position, but well, right now for this setup it's not very useful. We'll also see that in the next lesson. So we have our particles. Let's add a bit of gravity. And also some noise amplitude. Let's see what happens if we have a huge value. Yeah, we don't want that mess. You will see that the pulse length is a bit fast. And these particles go up and down. That's not what we want. Also, we want to lower a bit the particles. Let's set up a higher pulse length so animation is not that fast. Okay, that's not that bad. You can play around with these values. You can also add another pass of turbulence, add I don't know, a bigger soul size pass or whatever. Particles should be always falling. I see that some of them go up a bit, so that's a bit better. So let's get things clear. Let's put the flag on our out. And let's name this guy Wind Turbulence. Okay, we can add also some extra variation. What back here? We have an error. Now, let us mass let me turn off this guy just to see what's going on. You will see that your mass won't have. Sorry, I need this too. If we play this guy and we change the mass, we won't have any variations, any extra result. This is why every node has an option turned on by default that it's enormous. You will have to turn off this guy so this value will be affected. Now you see that we have slower and faster particles again. This is because we have there's not bad. Something happening here. Okay. So if you get higher values here, remember that the particle will be very slow. We don't want that, so let's give this number under 1. I'm not sure. I won't use any pop drag here. Okay, so now we have our particles driven by. Let's add some extra random here. We have our particles driven by our initial velocity. Also, we have some extra nodes. And now let's add a grid for collision. And let's add also an event. There's here up in the shelf you can get a collision tab. By default there's a ground plane. Let's use for now this one. If you click that guy, you will see that a grid, a kind of grid, will be created with some arrows. This ground plane is infinite, so it doesn't matter where you have it placed, it will collide in the zero of your grid. It will create a node that it looks this an object merge that we've seen it recently, that will point to this object. If you click the arrow, it will go to that place. So this will happen inside the PubNet, not big deal. You will see that other part of the tree has been created. If you press L, everything will be organized. And now we can see we have a ground plane. If you click it here, it will object path our ground plane, and you have our physical attributes, bounce and friction. Bounce is how high or how many times the object will bounce when it collides, and the friction it's how much the particle will slide in this object. Sorry, let's low a bit the particles just to see in a clear way what happens. Sorry, and this ground plane is connected to a static object. This will make the collision. You can add as much as static objects you want. We will work on collisions later on, but for now this is a bit how nodes are arranged. Okay, now we see we have a bounce, we have a friction occurring here. Also, you will see that the particles, once collide, they will turn red. This is why we turn on the color hits. If we turn this guy off, won't get any effect. And here, under response, you can change the action of this particle. If you want the particle to die once collide, it will disappear. You can also make it stop. The particle will lose the entire velocity. It will stick to the surface, or it will slide. Let's keep as unchanged, so we keep our bounce. What happens if we modify our bounce to 5? We'll see we have a higher bounce of each particle. 0.5 was not that bad. Let's keep at 0. We don't want so we see better the friction tab. We'll see some particles sliding, so the lower the value is, the more the particle will slide over the surface. It will get super high values. We'll see that no slide will occur here. Also remember that you can add some random to this object per particle, so each particle will slide in a different way. Now it's turn it on, so you'll see how some particles slide, some others stay still. If we turn off this, we'll see how every particle will move. So our random attributes are working pretty good. For now, I don't want friction. So, okay, here we have our particles. On the pop network, what I get is some points, creating a lot of options to work after with. But as you know, drops are spheres. So once again, we can play with our copy stamp node. And add a sphere. Let's plug this point, this sphere. They're huge. Okay, here we have our rain. And one thing is going on, and we don't want it, is that this copy node take all points of this output, and we'll see that also is taking out our grid. We don't want that. We want also particles points, no primitives. So we can add a delete node. And this is easy. You select only the entity as primitive, and the pattern set them to all. So now you see you won't have any particles on your surface. Okay, we have our rain setup. The next week we will add the collision events, just to see what happens when we will save the collision event into a group, and this group will emit particles. Let me finish tidying this. So we have everything clear. Okay, let's save this. And well, in the next class we will we will add other passes of this same rain. We will set them for render also, because these particles they need motion blur just to look like drops, real drops. And we will also work on the collision event. So that's it for now. Try to replicate this same setup, play around with the forces values, randomize, work on the meter, do your own setup. Also, I don't know, you can rotate your grid plane and play around with this. I don't know. Just post your version and see you next week, and let's finish this setup as